Hey everyone, and welcome to the Retro Channel, and today we are checking out this thing, the JVC A-X1 stereo amplifier from 1980. I picked this thing up a couple of years ago for I think about 20 bucks in unknown conditions, so I thought it's finally time to actually test this thing out, see if it works and what it sounds like, and if it doesn't work, see if we can fix it. So around the front here we've got a nice chunky power switch. There's two sets of speaker outputs, a LED driven power meter, obviously bass and treble controls, which have a nice sort of clicky feel as you turn them. So there's little notches every 1/10 of a turn, I guess. We also have a nice big chunky volume control, which isn't indented, so this just turns fairly freely, possibly a little too freely. There is also a balance control, which also seems to turn freely, although there is a little indent when you have it in the center position. And finally, some different selectors for the various inputs available on this thing. Obviously, this is just an amplifier and not a receiver, so there's no tuner built into this thing. And if we take a look around the back, and I've just noticed that the label from the back has just fallen off, so yeah, we're off to a good start, I guess. We find all our various inputs and obviously the speaker terminals. So the tape connector does use a DIN input for tape 1, so you could always use a 5-pin DIN plug and have both record and playback coming through a DIN connector. There is, however, also just regular RCA jacks for tape 1 and tape 2, and the same goes for the tuner, auxiliary, and the phono input. Obviously, our speaker terminal binding posts, these are just fairly regular screw ones, and of course a few safety warnings, and the label that fell off obviously has our model number, power ratings, and a serial number of, if I can read it, 076019000, and whatever that means. So I'll try and reattach that later on. We won't worry about that too much for now. I think what I want to do is open this thing up, take a look inside, and then we'll plug it into power and see if anything goes bang. Right, here we are on the inside. Yeah, plenty of open space in here. This is a Class A, or what JVC terms a Super A class amplifier, which I think is just a fancy term for maybe Class AB, probably just marketing BS. This thing is only rated at, I think, 30 watts per channel, but the total harmonic distortion is listed at 0.007%. Even my Technics amplifier doesn't match those figures. So yeah, plenty of open space in here, but I do see a couple of things that are concerning. This reefer capacitor in the power supply here, it doesn't look to be in too bad condition, but yeah, I'd rather not have one of those explode and release the nasty reefer smoke in this room. So glad I opened it up before powering it on. Apart from that, everything else looks good, except for a lot of heat buildup over here near these resistors. You can see the board has gone quite dark in this area. So I don't know about those two diodes. Probably these electrolytics might not be too happy, but that's not a big concern right now. The main thing is getting this reefer out, and then we'll power it up. And while we're here, let's just do a quick check of that fuse. Make sure it hasn't already blown in the past. No, it's still intact. Looks like it's just clipped in, this little board. We can turn it over just enough to get that reefer out. All right, there it is. Yeah, it is definitely cracking on the inside, but I've certainly seen a lot worse. So it probably wouldn't have exploded straight away, but you just never know. Pretty sure I've got replacements for this on hand, but even if I didn't, we could run this without the capacitor. It'd still work just fine. Unfortunately, even though they provided a couple of different footprints, this one is still slightly too small, so I'm just going to have to splay the legs out a little bit. Should we check those resistors, see if they're open? Probably should. So they're supposed to be 820 ohms. Oh yeah, still 800, 800. Let's have a look at these two diodes as well. It looks to be charging up a capacitor. Same with that one. And in the other direction, much of the same. So yeah, can't really measure them in circuit, it seems. Hopefully they're still good. There's only one way to find out. Well, technically there's other ways to find out, but this is the fun way to find out. Right, I'm going to use my dim bulb and stick a 60 watt globe in here. This will just help limit the current in case there is some kind of major fault with this amplifier. So what we should see when we power it on is this thing light up and then slowly dim basically as these two bulk capacitors charge up. I think that'll make up most of the initial current draw. So if the bulb stays lit constantly, then we know we've got bigger problems. Right, so we'll power this on over here and then I'll flip on the mains and see what happens. Well, the dim bulb lit up and then quickly went dim. Everything looks to be pretty happy. And it looks like a couple of seconds after power on, we get a little click from this relay, which I guess is enabling the speaker outputs. So before we plug in any speakers, let's just make sure there's no major DC offset on the speaker outputs, like we might have a shorted power amp like we did with the Technics. And then if that's all good, hook up some speakers, give it a proper test. Do we actually have... No, the speaker outputs were turned off, so probably need to do that first. Seems okay. Seems okay. Yeah, all seems good. Okay, we've got some crappy speakers. These are the ones that normally live in my garage and just usually have the radio playing through them when I'm working on the car. So yeah, I'm not too fussed if I accidentally kill these things. I've also plugged in a source into the auxiliary input and we're currently on auxiliary. Volume is all the way down. Let's power on. So it should currently be playing. Let's bring the volume up. Okay, we've got right channel. No, we've got left channel. Okay, well that's weird. I first had sound from the left channel and nothing in the right, and then after a few seconds I only had sound in the right channel and nothing from the left. So music is still playing. Let's power that on again. Okay. Unfortunately, this is only a mono microphone, but it started off in this speaker and then after a couple of seconds switched to that one. I don't think that's a problem with having the dim bulb in line. Doesn't sound great either, but maybe that is... Although the dim bulb's not lighting up, so... Ooh, okay. All of a sudden I've got both channels. Is it just a volume control thing? No? That channel sounds terrible. Left channel sounds fine. Something not right about the right channel though. Okay, dim bulb is out of circuit because I think we're pretty safe to run this without that. I'm just going to send a 400 Hertz square wave tone into this thing and see what it looks like on the speaker outputs. Unfortunately, I don't really have a dummy load for these speakers, so I'm going to use the speakers themselves as the load, but I might just put them down on the floor so they're not too annoying. And yeah, the negative terminal of the speaker output should be, the same as ground. So if we just look between the chassis and these, just a bad connection. Well, okay, so we've got 100K between the chassis and the negative terminal. That could be a problem. Yeah, the right channel seems to be, connected to the chassis as we'd expect. The left channel, 100K. Well, I've already pulled out the scope anyway, so we may as well take a look. Let's power this thing on and set everything to the mid position. Loudness is off. Volume is probably fine. We'll hook the scope up to the chassis ground. And let's first look at the left channel. So 400 hertz square wave. Okay, well, yeah, seems to work as expected, although we do have to turn the bass down quite a lot for it to square off. Seems about right. Let's go for the right channel. Ooh, that's a lot smaller and a lot less square. Yeah, that, we can get it close to a square. The scope doesn't want to trigger on it though. Yeah, not great, especially compared to the other channel. Both channels should look something like this. Right channel, however, certainly does not. 100k to ground on the right positive terminal, 0 on the negative terminal, and on the left, open on the negative terminal, 100k to ground on the right terminal. So, yeah, that's the problem there. But it seems like the right channel was having issues, even though it's the left channel that doesn't seem to have any ground reference. Well, there is a little board where all the speaker terminals mount to. Let's just have a look at that. Maybe there's just a cracked solder joint somewhere or missing connection. All right, I think that's free. Ew. Can't get it past the big caps. That's annoying. Right, that's enough just to get this board out. And there's definitely nothing on this board apart from a few jumper links, which are these things across here. So, negative terminals, jumper link in between. No, jumper links are going out this way. Oh, I think I might have found the problem. Yeah, it looks like that joint there is not making any connection. That's going to the blue wire, which goes somewhere. Oh, that blue wire heads onto the board near these capacitors, and yeah, that should be one of the negative terminals, specifically the negative terminal for the left channel. So if we go from chassis ground to where the blue wire comes in, yeah, we do have continuity. Oh, and now it looks like I've partially restored that connection, but yeah, just moving the board around messes that up. So yeah, bad joint right there. I think we'll just reflow all of this just to make sure everything remains happy. So I'll do these speaker terminals as well. Well, that certainly would have caused some issues. In fact, I do want to check if there's a DC offset now that we've restored that connection, because it was basically floating before. We wouldn't have seen any DC on it if there was some. And now that it's got a proper ground connection, there is a chance that, I don't know, I just don't want to risk losing any more speakers. 7 millivolts, should be fine. Right, so scope is hooked up to the left channel first. This is the one that was missing the ground connection. And yep, that looks pretty happy. It's a terrible noise, I apologize for that. Let's check the right channel. Play. Yeah, it's still very messy and gets a lot more distorted as we increase the volume, so definitely still a problem there. Probably should just make sure it's not this particular input, so let's swap over to the tuner input. That one. Still terrible. Okay, we've got some more digging to do. Right, well I think the first thing I want to check out are the components in this area where it's gotten a bit toasty. And I have just noticed that these two capacitors are Jamicom branded, which I think is what JCar in Australia sells. So yeah, somebody's definitely been in here and replaced whatever caps were there. The rest of the caps in here all look to be the same, and I'm guessing they're all the original ones. And the two capacitors down the back also look to be original. So looks like that's all the work that's been done to this thing, and maybe while they were pulling it out, they accidentally disturbed the connection going to the speaker terminals at the back. Maybe that's where the journey ended for this thing, but we're going to try and get it sounding good again. Oh, and I've just noticed none of these cables are actually in the cable tie thing. Oh yeah, so definitely some work has happened with those two capacitors. We already sort of figured that out. And the power amplifiers also look like they've been reflowed recently. Apart from that, I don't see any other evidence of any work happening in here. Well, I guess while we're here, we may as well check these transistors just in diode mode. Yeah, that looks fine. It's nothing shorted or anything. Yeah. Seems all about the same. Yeah. I mean, I didn't really expect to find anything there because, you know, we've obviously got normal, well, not normal, but we've got sound output, so they're, you know, they're not totally dead. Where's those two diodes? Those two. Definitely want to check them out. So it looks like the two diodes on the board have a common connection on one side, and on the other side they both go through those larger, quite toasty resistors, these guys here. So let's just, I don't know, remove one of the legs of the diodes just to make sure they're actually okay. It could be that there is something wrong with those diodes, and that's why our resistor is getting extra toasty, but well, there's one way to find out. All right, open in that direction, that's good. And the other way, yeah, 0.56 volts, 0.58 volts, close enough. Let's have a look at these capacitors that were replaced. See how they're faring. They don't look great underneath, but that just could be from the dirt on the board. So they're supposed to be 100 microfarad, 63 volt. Let's see. Yeah, 93. ESR is 214 milliohms, so seems good. 89, 237 milliohms, also seems fine. Just give the board a little clean under there. I should have cleaned under those diodes while I had them out. Yeah, well. Alright, those two caps are back in. I don't really see any other obvious issues on this board. It looks like there was some glue around these larger caps here, which has, you know, probably turned hydroscopic and gone very dark and crusty. But yeah, I don't think that's an issue with the caps themselves, but it is possible that this stuff can, you know, get on jumper links and then start to corrode them, so it is worth just trying to remove as much of it as you can. As long as this thing isn't being sent, you know, overseas, you don't have to worry too much about gluing down large components. It's only really for transit's sake. So I just cleaned up some of the nasty flux around all these power transistors and spotted a couple of things of interest. There is what looks like a little solder ball here. Obviously that mustn't be shorting those two connections, otherwise we would have seen it when we tested it before. But yeah, not fantastic to have that in there. Looks like there's a little one over here as well. Yeah, nasty. And the other thing that I spotted under all that flux is this little jumper link here, which looks to be missing a lot of solder on that side. So I wonder if it's actually making a connection. Should go from here. Yes, it is. Okay. Let's just give that a bit more solder. There we go. Right, well, some time has passed since that last clip. In fact, it's been a couple of days. I did spend a whole bunch of time just poking around with the scope at this thing, trying to find something out of the ordinary. I started off by checking the main voltage rails, and they were perfectly fine. I also found out that these two diodes down here are actually Zener diodes, and they set up a 15-volt rail, which seemed to be only used by this phono preamp board back here. But once again, those voltage rails were perfectly fine. So even though there's another hour worth of footage of me just poking at this thing with the scope and looking over the schematics, that didn't really turn up any useful results. So instead I went back to the previous footage that I've already recorded and started editing that. And that, of course, is where I spotted a clue. And some of you may have also noticed this. I guess that's the tricky part with filming YouTube videos. Sometimes you're so involved in just making the video that you overlook small details. So I guess it's a bit of a double-edged sword. It takes way longer to make videos on these things, but at the same time, you've got a practically photographic memory, assuming you've recorded it. So looking back at the footage, we obviously saw that there were issues on both the left and right channels, but I think I've worked out the reason the right channel looks so weird. As you can see, the waveform is sort of only going into the negative region. It only just comes up above the 0 volt mark. And that is because this is basically a Class AB amplifier, despite the Super A label on the front. It's more or less an AB from what I can tell. So basically with a Class A amplifier, you have only a single transistor, and the waveform going into the base is biased so that it sits between the maximum and minimum voltage rails. But with a Class AB amplifier, you have two transistors, one that amplifies the negative going part of the signal and another one that amplifies the positive going part of the signal. And from what we saw on the scope, we were only amplifying mostly the negative part. So clearly there's a problem with the positive going stuff that's just being cut off. And after pulling this thing apart and pulling out all the power transistors, unfortunately I didn't get that on camera, I did find a problem. So here we have all the original power transistors along with our reefer cap. Oh yeah, and there's a little electrolytic that I swapped out. This one was sort of reading, you know, marginal. It probably would have been fine, but I decided to replace it anyway. But that's not really important right now. So let's have a look at what reading we get from these transistors in one of these little component testers. We'll start off with one of the ones that was on the negative rail. I don't know if this was on the left or right channel. Probably doesn't really matter. So we can see it is coming up as a PNP transistor. Everything looks pretty good there. And likewise, the other PNP transistor should also test fine. And yeah, that looks all good. Now, if we look at the ones on the positive rail, so these should be NPN transistors. Okay, this one tests okay. NPN transistor looks all good, which means this one, as you can probably already guess, is not going to test the same. It just tests as a diode, and if we poke around at this with the multimeter, we can see which pin has gone missing. So on these, the leftmost pin is the base, middle pin is collector, and rightmost pin is emitter. So if we go from base to collector, 4.95 volts, pretty standard, but base to emitter, nothing. It is open. And likewise, collector to emitter, still open. Even swapping the probes around, of course, we get nothing there. Yeah, there is zero connection to the emitter of this transistor. So basically what we had was the signal going into the base, the collector was sourcing voltage, but none of that mattered because nothing was going to get out on the emitter. And therefore what we end up with is only half a waveform because we don't have the positive going side of it. Now, as you can hopefully see, I have already replaced all 4 of the transistors. I figured if I was going to be ordering one of them, may as well replace the whole lot at the same time, just so everything's sort of a bit more balanced and Hopefully it'll last a little bit longer, because who knows what other strain these other ones have been put under. So yeah, I've replaced all 4 power transistors, and that's as far as I've gotten. So I'm yet to plug it in. Hopefully I haven't made a mistake here, but yeah, we're going to find out once again. Okay, I think for the first power on test, we should put the dim bulb back in circuit, so I've done that. Let's hit the power button. Okay, the bulb lit up for a second and then went dim, and our relay clicked. So nothing has exploded. That's good. How's it going to sound? That's the next question. So once again, we'll throw in a 400 Hertz square wave. I've already got the speakers hooked up. They're just down on the floor. I guess we'll start off with the right channel, which was missing the positive going part of the waveform, and see what happens. Oh, I need to adjust the scope. Hey, there it is. Looking a lot better. So we have the positive and negative going rails. Scope's a little bit tricky to trigger on, but it's there. Not quite square, but it's there. Let's check out the left channel. Ooh. That's not very square at all. Okay, well, we fixed one issue, but there's clearly still more. Loudness is off. Treble and bass are centered. Let's hit play again. Okay, we can get that close. I think this is exactly what we were seeing before. So clearly we haven't fixed the problem with the left channel, but the right channel, if we readjust everything so it's centered, yeah, that seems to be working as expected. Terrible noise, I know. It almost looks like loudness is being applied all the time. In fact, pushing the button hardly makes any difference. I think it's just adding treble, but there's too much bass on that. Oh. If I just sort of, hey, there's a square wave. It's just a dodgy loudness button. All right, time to get some contact cleaner in all these switches and pots. Hopefully that's all we need to do. Guess we'll start with pulling knobs off. Ooh. Oh, I just realized that I didn't check the bias current for these new power amplifiers. Somebody remind me to do that. I guess otherwise I'll remember when I go to edit this. Right, well, there's some of our controls, all the input selectors, volume, balance, and the loudness switch. And we've got some space for some other stuff that wasn't populated. C on or off. C recording. Well, who needs to hear the ocean anyway? So I'm hoping I can just get a bit of contact cleaner just down past the switch, past the plunger. Hopefully that'll make it down to the contacts in there. Oh, that seems happier. So we'll give these a go while we're at it. I do love a clean knob. Okay, power on. Still set to the mid position on everything. Let's go. I hear nothing. Turn up the volume. Alright, still doesn't look ideal. But it's working as expected. Okay, before we go any further, I need to set up the bias current for these new transistors. So I think these are the two controls for the transistor bias adjustment. Oh yeah, here we go. Before turning on the power, already did that. Turn the semi-fixed resistors R627 and R628 fully counterclockwise. That one. Adjust the semi-fixed resistors so that the voltage at the following test points of the power amplifier circuit board is within the range of 10 millivolts to 14 millivolts after the power is turned on. That's why these little resistors have pins sticking out the top. All right, I have to get some backup for this one. Bring out the old fluke. Still works. Of course it does. Right, let's power on, see what we get. Well, that's already going up to 15, 16. Okay, maybe that variable resistor seems to be dud right at the end of its turn, so maybe it's not a good idea to turn them all the way counterclockwise. All right, that one's slowly coming up. Let's do the other one. Here we go. All right, we're sitting at about 11 millivolts and 12 millivolts. We need to give it a few minutes just for these to heat up, and then readjust resistors after 5 minutes to 12 millivolts. Well, it's been a few minutes and both of these are at 12 millivolts, so I think we're good here. Funnily enough, the camera over there just shut down because it overheated. So I think things are sufficiently warm at the moment. All right, the amplifier is all back together. I gave it a bit of a wipe down, so it's looking pretty. And I also tested it out with a few more familiar tracks and a half decent pair of speakers. And I can say that while it sounds good, it's not going to replace the Technics receiver that I've got in here. It's very bright. It's crisp. I actually backed the treble off a couple of notches and then it sounded a little bit more pleasing to my ears. And it seems I'm not the only one, as while I was looking around for the service manual online for this thing, I read a few similar comments. So I guess it's not a fault with this particular amplifier, that's just how these things sound. But let's play a track that I can actually play from the YouTube music library. Help if I turn the power on. So yeah, I would say it sounds actually better when the speakers, or at least the tweeters, are not directly pointed at my ears. But when they are, I found that backing the treble off a couple of notches made it sound a lot more even, a bit more flat, which I actually kind of prefer. Turning the loudness on does what you'd expect, but yeah, that makes it way too bright for my ears. But in saying that, I've certainly heard a lot worse, and if this was the only amplifier that I had around, I'd be perfectly happy with it. So yeah, I guess that is it for this one. Thank you all for watching. A huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are down in the video description. You'll get ad-free early access to all videos, along with helping support the channel and keep these videos coming, and also discounts on the Tindy store and the occasional behind the scenes stuff. But yeah, that is it for now. Let me know what you thought. Leave comments down below, like, subscribe, blah, blah, blah. I will catch you in the next one. Bye. Is biased so that oh fuck.